and welcome to day one of Coding Kids Microlearning series. In today's video, we'll be talking about computational thinking. So what is it? What does it entail? How can it be used to solve problems? How can it be taught? At the end of the video, don't forget to do our mini quiz on computational thinking. As I mentioned in our introductory video on Friday, as part of our microlearning series, you'll also have the opportunity to complete 10 mini quizzes, one at the end of each video. If you complete all 10, you'll receive the Teacher PD Microlearning Certificate for completing 1 hour of Teacher PD. To take part in these daily mini quizzes, check out the link in the description. Now, Eloise, you ask, what is computational thinking? Well, within the digital technologies curriculum, there are 3 approaches you can take to a problem solving: design thinking, systems thinking, and computational thinking, which we'll be talking about today. Computational thinking involves defining a problem and expressing the solution in such a way that a person or machine can systematically carry out the instructions. This method of problem solving involves, first of all, decomposition, also known as breaking down data processes or problems into smaller, more manageable parts. Number 2 is pattern recognition. So this is being able to notice patterns, trends, and regularities in data. Third is abstraction. So the removal of unique characteristics for the purpose of reducing something to its essential characteristics. And finally, number 4 is developing step-by-step instructions for solving this problem, as well as other problems of a similar nature. So let's look at what each of these steps mean in the context of building a simple maze game in Scratch. For those of you who haven't heard of it, Scratch is a free online platform that allows you to build digital projects, such as computer games or animations, using drag and drop coding blocks. It's a great way to learn how to build digital projects without all the difficulty of your typical industry standard programming language. So I'm going to just swap the camera around if it'll let me. It's not going to let me, that's all right. I'm just going to flip you around in that case. So just here we have a really simple maze game, and I'll move the monkey around. My camera wants to stay still. So it's totally functioning. I can move them around using my arrow keys and left and right. And then if I touch any of the walls, then he's going to pop back. Oh, he doesn't want to let me. That's okay. We'll try doing this. Green flag. And now, there we go. Really, really simple. Okay. Let me just put that back up. There we go. So let's look at those fancy terms we learned earlier in the context of building this maze game. So decomposition. We have quite a large project in front of us. So how can we break it down into smaller and more manageable pieces? Well, we can decompose this maze game into smaller parts by thinking to ourselves, all right, what do I need to do to include in this game? What do I need to include in this game? Sorry. I need a monkey to move around. I need maze walls that he needs to navigate through. And I need bananas to mark the goal. In this way, you've decomposed a maze game into a game that requires a monkey, a maze, and bananas to work. Let's move on to pattern recognition. Now, for this to be a maze game, we want to program the monkey to move up, down, left, and right in the 2D space, right? Once we learn to program the monkey moving in 2 or 3 of the directions, we begin to notice that there's a pattern to write in the code that makes the monkey move in all 4 directions. Now let's talk about abstraction. So in our maze game, we want to control what happens when the monkey touches the walls and when he touches the bananas. Now, knowing how to code a monkey touching a banana might not be relevant in your next game if it's about catching a fish, but it's likely that you'll still use the same fundamental blocks when coding how to catch a fish in a net. That's what abstraction is. It's the removal of unique characteristics for the purpose of reducing something to its essential characteristics. So even though we might never need to know how to code a monkey touching a banana again, we can abstract the fundamental concept behind it and apply it to other projects that we make. So finally, let's talk about algorithm design. When we build our maze game, we learn to develop algorithms, or sets of instructions that your computer needs to complete, that express the solution to our problem in a general term. In our maze game, we have a monkey that has to navigate through a purple maze to get to a banana. If we wanted to build a maze game that has a cat that needs to navigate through a pink obstacle course to get to a bowl of milk, the algorithms used wouldn't be exactly the same, but they would be very similar. We can reuse our knowledge of old projects to inform algorithm designing instinct. And that's all it is. There you have it. Computational thinking is one approach to solving problems. It focuses on having you define a problem and express the solution in a way that a person or machine can carry out the instructions. It's comprised of 4 parts: decomposition, pattern recognition, abstraction, and algorithm design. And that's all for today. Thank you for tuning in. Don't forget to click on the link in the description if you want to take the 1 to 2 mini quiz. A reminder, if you do all 10 quizzes, you'll receive a certificate for 1 hour of PD. Tomorrow we're going to be looking at what is coding. And this has been Eloise, signing off. I'll see you tomorrow.